Now, once we've established the right triangle definitions of the 6 trigonometric functions, we can start to talk about the idea of trigonometric identities. And trig identities are formulas or equations that relate the 6 trig functions to one another. In Unit 3, you're going to see a lot more of these. We're going to see some fairly complicated ones. All the identities we're going to do today relate pretty naturally to the right triangle definitions. And it's one of the really neat things about trigonometry, the fact that we can take a trig function and rewrite it multiple ways using different trig functions. It allows us a lot of flexibility. It allows us to answer a lot of questions involving trig functions. And if you're going on to take calculus, it's something you're going to lean on a lot in that course. So in this video, we're going to look at the fundamental trigonometric identities. The first trigonometric identities we'll look at are the so-called Pythagorean identities. So there are 3 Pythagorean identities. They all relate the squares of the trig functions to each other. So the first Pythagorean identity, and the one that you should definitely have committed to memory, is that sine squared theta plus cosine squared theta is equal to 1. Okay, very important, comes up a lot. And we can actually derive the other 2 Pythagorean identities from this one if we forget them. Okay, so the second Pythagorean identity is tangent squared theta plus 1 equals secant squared theta. And finally, cotangent squared theta plus 1 is cosecant squared theta. Okay, now, if you've never seen this notation, sine squared, cosine squared, tangent squared, and so on, all this means is, sine squared of theta is the sine of theta squared. So that is all that means. You take the sine of theta and you square it. So to just do an example before we jump into why these Pythagorean theorems are true, if we were to look at, for example, the angle 30 degrees, we looked at sine squared of 30 degrees plus cosine squared 30 degrees. Okay, so if you recall from our definitions of the trig functions for the angles in our special right triangles, the sine of 30 degrees was 1/2. The cosine was square root of 3/2. Okay, so the sine squared of 30 degrees is 1/2 squared, which is 1/4. Cosine squared of 30 degrees is square root of 3/2 squared, which is 3/4. And 1/4 plus 3/4 is equal to 1. So the Pythagorean identity sine squared theta plus cosine squared theta equals 1 works for the angle 30 degrees. Okay, this is true in general, and we can prove this for a right triangle by just using our trig ratios. Okay, so if we do sine squared theta plus cosine squared theta, so sine theta, again, is opposite over hypotenuse. Okay, so we're going to square that. Cosine squared theta is adjacent over hypotenuse squared. Okay, so that's going to give us opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. Here we have 2 fractions with a common denominator, so we can add their numerators together. So we get opposite squared plus adjacent squared over hypotenuse squared. Okay, now, and this is why we call them Pythagorean identities, from the Pythagorean theorem, opposite squared plus adjacent squared is hypotenuse squared. So we can rewrite our numerator as hypotenuse squared. Hypotenuse squared over hypotenuse squared, which is just 1. Okay, so that's the proof of the first Pythagorean identity. I'm not going to go through the details of the other two, but they are very similar. So what we can actually do here is write the second Pythagorean identity as secant squared theta minus tangent squared theta equals 1, and the third one is cosecant squared theta minus cotangent squared theta equals 1. And then we're going to do a similar calculation by writing everything as fractions, combining the fractions, and then using the Pythagorean theorem. Okay, so that is the Pythagorean identities. Okay, so the next set of formulas we're going to look at involve taking quotients of our 6 trig functions. Okay, these are the so-called quotient identities. Okay, so there are 2 quotient identities. The first is that sine theta over cosine theta is tangent theta. Okay, the second is that cosine theta over sine theta is cotangent theta. Okay, so those are our 2 quotient identities. They relate tangent to sine and cosine, or cotangent to sine and cosine. Okay, once again, if we use the right triangle definitions of sine, cosine, and tangent, this is a really straightforward thing for us to verify. So before that, if we were to do a specific example, we looked at, for example, the sine of 30 degrees over the cosine of 30 degrees. The sine of 30 degrees, again, is 1/2. Cosine of 30 degrees is square root of 3 over 2. Okay, so that's going to be 1/2 times 2 over the square root of 3. Since dividing is the same as multiplying by the reciprocal, so dividing by root 3 over 2 is the same as multiplying by 2 over root 3. 2's on the top and bottom cancel, and we're left with 1 over the square root of 3, which, remember, was the tangent of 30 degrees. Okay, so there's a specific example. If we want to use our right triangle definitions, we can use the fact that sine theta over cosine theta is opposite over hypotenuse divided by adjacent over hypotenuse. Okay, and the hypotenuses will cancel out, and we'll be left with opposite over adjacent, okay, which is exactly the tangent of theta. And the cotangent identity is very similar. So now we're going to have adjacent over hypotenuse divided by opposite over hypotenuse is adjacent over opposite, which is exactly the cotangent. Okay, so that is the quotient identities. Okay, now the next set of identities I'm not going to prove because they come pretty naturally from the 6 definitions of the trig functions. So you can refer back to that video if you do have questions about it. These are the so-called reciprocal identities. Okay, and this just relates back to the fact that certain trig functions are reciprocals of other trig functions. Okay, so for example, cosecant theta is 1 over sine theta. Okay, so we saw that when we were defining the 6 trig functions. And similarly, if we were to take reciprocals of both sides of this equation, we would get sine theta is 1 over cosecant theta. In other words, sine and cosecant are reciprocals of one another. Similarly, secant and cosine are reciprocals of each other. So secant is the reciprocal of cosine and vice versa. And finally, cotangent and tangent are reciprocals of each other. Okay, so once again, those come very naturally from the definitions of the 6 trig functions using ratios, so I won't go through the effort of actually verifying them just for the interest of time. The nice thing about the reciprocal and the quotient identities is that we can actually take any trig function we want and write it in terms of sine and cosine. That's going to be something powerful that we will exploit later on when we're trying to prove other trigonometric identities, because cosecant and secant can be written in terms of sine and cosine, and then using our quotient identities, cotangent and tangent can be written in terms of sine and cosine. So what that means is if we know the sine and cosine of an angle, and in fact we just need to know one of those because we have the Pythagorean identities. So using the Pythagorean identity, we can find the cosine of an angle given its sine or vice versa. So if we have the sine, we can find the cosine using the Pythagorean identity, and then using the sine and cosine, we can find the tangent, the cotangent, the secant, and the cosecant. So really we just need to know one trig function value, and we can find the other 5. That's really very convenient, and that makes sense because going back to right triangles, if we know one of the trig function values, we have to know 2 of the sides of the right triangle, and therefore we can use the Pythagorean theorem to find the third side, and then we can find all of the trig function values. Okay, so in a future video, I'll work through some examples where we can kind of see that in action using both the identities and the right triangle method. Okay, and then the final set of identities we're going to look at are the so-called cofunction identities. Okay. So you may notice that our 6 trig functions are in co-pairs. So we have sine and cosine, we have secant and cosecant, we have tangent and cotangent. And it turns out that a trig function and its so-called cofunction have a relationship if the 2 angles in a right triangle add up to 90 degrees. So if we have 2 angles that are so-called complementary, if there are 2 acute angles in a right triangle and they add up to 90 degrees, we can say things about the trig functions of one of the angles in terms of the cofunctions of the other angle. Okay. So to motivate this, note that if theta is one of our angles, then the other angle is 90 degrees minus theta, or if we're in radians, pi over 2 minus theta. Okay, because again, all 3 of our angles have to add up to 180 degrees, so theta plus 90 degrees minus theta plus 90 degrees is 180 degrees. Okay, so looking at that, we note that, for example, the sine of theta is equal to the cosine of 90 degrees minus theta. So we saw this when we were working with 30 degrees and 60 degrees. Remember, the sine of 30 degrees is the cosine of 60 degrees, etc., etc. Okay, and that's because the sine of theta is this side over this side, the opposite side over the hypotenuse, but the cosine of 90 degrees minus theta is the same ratio, because now this side is the adjacent side to 90 degrees minus theta. So it's going to be this side over this side. So the ratios are the same. And again, we can do this with 90 degrees, or we can do it with pi over 2. So it's going to be the same thing as the cosine of pi over 2 minus theta, depending on if you're in degrees or radians. Similarly, cosine of theta is the sine of 90 degrees minus theta. Okay, so sine and cosine are our first cofunction pair. Similarly, for secant, secant of theta is equal to the cosecant of 90 degrees minus theta. Okay, and the cosecant of theta is the secant of 90 degrees minus theta. Okay, and finally, the tangent of theta is the cotangent of 90 degrees minus theta. And the cotangent of theta is the tangent of 90 degrees minus theta. Okay, so that's the relationship between each function and its co-function, sine and cosine, secant and cosecant, tangent and cotangent. That if two angles are complementary, that is, they add up to 90 degrees or pi over 2 radians, the trig function of one of the angles is going to be equal to the co-function of the other angle.